Okay, reference angles and exact values. This is chapter 9, part 2. It's the third day. Let's see. Let's go right over here. Let's start with this. The sine of the angle is given at 9/11. Find the 6 trig ratios. So what we're doing here is just basically the SOHCAHTOA, and we'll be using that extensively. So I always draw a triangle. All my triangles kind of look the same. Opposite over hypotenuse, 11 and 9. Pythagorean theorem will tell you the third side. Square root of 40. Square root of 40 could be changed to 2 square root of 10. And now I can find the sine is what was given. And the cosecant is flip that over. The cosine is adjacent over hypotenuse, and this would be exact value, so I don't use the decimals. Secant, flip that over. 11 over 2 root 10. We'll get back to that in a second. Tangent, opposite over adjacent. Cotangent, flip that over. You do need to multiply the top and the bottom of these by root 10, so you get 9 root 10 over 2 times 10 is 20. Over here you get 11 root 10, 2 times 10. Remember, we're going to multiply by square root of 10, so you're going to get 20. Those would be the 6 trig ratios. Talking about on a graph now, you got an x-coordinate and a y-coordinate. We always make our right triangle with the x-axis, so I'm going to go 3 units to the right, and I'm going to go 6 units up. And I'm going to have my triangle is always with the x-axis. That's very important. And then we can find the hypotenuse by using the Pythagorean theorem. I believe that's going to be what? 3 squared plus 6 squared equals c squared. 36 and 9, 45. So c is root 45. If we broke that down, that would be square root of 9 times the square root of 5, 3 root 5. And now we can find the 6 trig ratios exactly the same way we just did it. Sine of the angle is equal to opposite over hypotenuse, which could be written as 2 over root 5 if we simplified it. I'd flip that over for the cosecant. I flipped these over before I change that, rationalize that denominator, because then it makes this easier, root 5 over 2. Now I can change this to 2 root 5 over 5. Again, we're multiplying the top and the bottom by root 5. And then I can do the cosine is 3 over 3 root 5, which is actually 1 over root 5. Flip that over for the secant. Root 5 over 1. Multiply the top and the bottom by root 5. Root 5 over 5. Tangent is going to be 6 over 3. 6 over 3 is 2. Flip that over for the cotangent, and you get 1 over 2. Reference angles are formed, angle formed with coterminal side of angle in the x-axis. And we always deal with this. We call this the bow tie. So if I'm in quadrant 1 and I draw an angle and I end right there, and this is my terminal side, so we're always talking starting there. That's going to be my reference angle, whatever is right there. As I go to quadrant 2, this is my, so I'm going to talk about this angle, and I'm going to talk about this angle. So if I went around to quadrant 2 and I stop right there, that's my reference angle. Quadrant 3, if I go down here, I do this guy. Quadrant 4, if I go all the way around, this is my angle. So I always draw a bow tie. It's a great way to remember that you need to be using the x-axis. This is the x-axis going this direction, and your right triangles and your reference angles are always formed with the x-axis. So you need to pay attention to which angle needs to be used. So when I look at these angles here, I'm going 135 over. My reference angle needs to be this one. How short am I of 180? I'm 180 minus 135 will give me 45. The reference angle here is 45. Remember the bow tie. I come around. How far past 180 did I get? How far past 180 did I get? I got 30 past 180. So this one's 210 minus 180. Over here I went to 300. And again, this will always be my reference angle, very important. That's going to be 60 degrees. So if you had 300 degrees, you're actually going to use a reference angle of 60. Now we're going in a negative direction. Again, we end up at negative 240. Really, they went negative 120 this direction. This is a little screwy. My main thing here is how far am I in between this? I'm 60 degrees in there. And then how far past did I go over here? I'm 30 degree past. And then all the way around 225, I'm 45 short. So it's all about the terminal side and the x-axis. The terminal side and the x-axis. The terminal side and the x-axis. And what angle is formed with the x-axis. Find each reference angle. So I'm looking for this angle right here. That skinny one right there. That skinny one right there. How short am I of 180? I am 17 degrees short. That would be 180, but I'm minusing off the 163. Whoa, 163. Over here, these ones are kind of nice in quadrant 1 or a negative in quadrant 4. The reference angle is always positive, and that's just a 70 degree angle. When you're talking radians, I see students do this a couple of different ways. One way to think about this, though, is if that distance is 1 pi, and 1 pi could be written as 6 pi over 6, I like to look at it as how short am I of 6 pi over 6 if I stopped at 5 pi over 6. I'm 1 pi over 6 short. And if you hate radians, then convert this. 5 pi over 6 is get rid of radians, go to degrees, and we get 150. Since we're talking 150, you could also look at this as 30 degrees. And there's nothing wrong with doing it in degrees. Pi over 6 is 30 degrees. 35 pi over 12. 36 pi over 12 would be 3 pi, which is 1 pi, 2 pi, 3 pi. So again, how short am I of 36 pi over 12? I'm 1 pi over 12 short. I'm 1 pi over 12 short. Again, you could do this in degrees. Might be easier for some people because you don't speak fluent radians. This is 525 degrees. If I take out 360 degrees, because that's one trip around, I'm really talking about 165 degree angles. So this right here is 165, and what am I short? 180 minus 165, I'm 15 degrees short, and pi over 12 is 15 degrees. So you can do it in degrees if you so choose. The coordinate plane is going to be very important for what we're doing, and this is going to go back to the bow tie, and this works anywhere on here. I get x and y. So I'm talking about this angle, and this could be down here in quadrant 3, where we go x and y, and then we have a radius. So this is a radius of a circle. So on that radius, I have the sine is equal to the opposite over the hypotenuse, and the cosine is equal to the adjacent over the hypotenuse, and the tangent is equal to the opposite over the adjacent. So if you know an x-coordinate and a y-coordinate, you can use the Pythagorean theorem to solve for r, and then you can find any trig ratio anywhere you want. These are going to be great for our quadrantals. These are called the quadrantals when they stop right there. We'll talk more about those later, but since I know that the sine is the y-coordinate divided by the radius, your life will get a little bit easier, especially for those quadrantals. So you're going to want to keep track of this. You don't have to memorize it, you need to be able to produce it. So anytime you have these types of problems, you want to produce this triangle right here with the x and the y and the r. Sine is the opposite, cosine is the adjacent, and then you're in good shape. So for a problem like this, I would look at this one as 8 to the right and 15 down. We use the Pythagorean theorem, and we find that r here is 17. Notice I'm in quadrant 4. My reference angle would be considered right here with the x-axis. So now when I'm finding the sine of my angle is the opposite over the hypotenuse, that's negative 15 over 17. The cosine is the adjacent over the hypotenuse, 8 over 17. Notice sine is negative in quadrant 4. More on that later. And the cosine is positive in quadrant 4. And then the tangent is equal to the opposite over the adjacent. And tangent is always a little bit funky. And then the cosecant, what do? We flip it over. And then the secant, we flip over the cosine, 17 over 8. Oh, not 18. Get rid of that. Sorry, got a little problem there. And then the cotangent is negative 8 over 15. So I've got, I can find the sine, cosine, tangent. And remember, can't forget, the sine and the cosecant start with different opposite letters, and the cosine and the secant start with different letters, and that's a great way to remember which one goes with which. And then tangent goes with cotangent, and if you can't make that association, I'm not sure how much I can help you. Here we go again, x-coordinate, y-coordinate. Again, we can go 3 to the left, and, I'm going 4 up. I better get an eraser. I'd hate to make my first mistake of the day. And so I'm going to grab a pen back here. Maybe let's go to blue. This red is blinding my eyes. So I'm going to go 3 left, 4 up, and then I have, that 3's in a terrible spot. I need an eraser again. Sorry about that. Okay, let's clean this up. So we can plan ahead a little bit here. All right, so we're back to the pen. So minus 3, positive. You got to watch out for these negatives, right? The left is negative, up is positive. And I can do the Pythagorean theorem, and it's 5. If you don't believe me, try it. And now this is the angle I'm always working with. And notice I have an x-coordinate, and I have a y-coordinate, and I have an r. And we can follow that same x, y, r will work for everything. Anytime we're on here, the sine is always the y over the r, and the cosine is always the x over the r, and the tangent is always the y over the x. Or you can just look at the picture, and I know that the sine is going to be the opposite over hypotenuse. Hey, look at that. Sine is positive in quadrant 2. Coincidence? No. Cosine is negative 3 over 5, adjacent over hypotenuse. Ka! And the tangent is opposite over adjacent, and so sine is positive in quadrant 2, and tangent and cosine are negative. And then can you flip those over? Cosecant, flip it, 5/4. Secant, flip it, negative 5/3. Cotangent, flip it, negative 3/4. And you're good. All right. Okay, this is going to be some of the most important stuff that we do all year. First of all, I referenced back to the fact that the sine was the y-coordinate. Y over the r, and the cosine was the x over the r, and the tangent was the y over the x. And if we think about this S, T, C, that's which one is positive where? Everything is positive in quadrant 1. The sine is positive in quadrant 2. How come? The y-coordinate is positive in quadrant 2, which means our opposite is positive, and the r is always positive for these problems. And then the cosine, the x-coordinate. That means our x-coordinate is positive when we move out to the right. That means in quadrant 4 we have a positive. So sine is positive, the other two are negative. Tangent is positive down here. How come? It's a negative divided by a negative, which is a positive. And then over here, cosine is positive and the other two are negative. So when we find exact values are simplified square roots. You're going to need to know your 30, 60, 90s, and 45, 45, 90s. If you haven't committed that to memory yet, you need to do so. I prefer to remember them like this, 1, 1, square root 2, and I use the ratios. And then I prefer the 30, 60, 90 as 1, 2, square root 3. Please remember that the side opposite the 30 is the one you work off of. It's always going to be opposite the 1. And so now what we do is we find the quadrant. I go over here. And now we go, we need, let's do this one as sine of 135. Sorry, I don't think I put that on there. So I'm in quadrant 2, sine in quadrant 2. So I know my answer is going to be positive. And so that's the first thing I do. Get your plus or minus. Second thing, Bow tie, reference angle. If that's 135, how far short am I? I'm 45 short, which means I'm going to use a 45, 45, 90. I'm using this guy right here, 45, 45, 90. Sine is opposite over hypotenuse. So I know that the sine of 135 is equal to the positive 1 over the square root of 2. We don't really write the positive. I just want to make sure that you understand what we're doing there. And then we should know that that's actually square root 2 over 2. My exact value for the sine of 135 is square root 2 over 2. Your calculator will not tell you the exact value. It will tell you the decimal equivalent. Coming over here, 120. Sine 120. I'm over here, 120. I'm 60 short. The bow tie tells me that I'm going to use a 60-degree reference angle in quadrant 2. STC. The answer is positive. Now I need my 30, 60, 90. I'm at the 60-degree angle, opposite over hypotenuse. Look at your triangle. 30, 60, 90. 1, 2, square root 3. Square root 3 over 2. It's positive. Tangent of negative 300. Come around 300. How far short am I? I'm 60 short. Hey, quadrant 1. Everything is positive in quadrant 1, and I'm 60 degrees, opposite over adjacent. OA, tangent, OA. So we're doing the same things we've been doing here. Square root 3 over 1. That's my answer. 240, cosine. First thing I do, step 1, come around 240. How far past bow tie? Where does my bow tie sit? It sits right here, and I'm going to be 60 past. But I'm in quadrant 3. Notice tangent is positive in quadrant 3. The other two are negative. My answer will be negative. You want to make note of that. Now I need a 60-degree reference angle. Look at your 60, adjacent over hypotenuse, 1 over 2. My answer is negative 1 over 2. Cotangent, I never work with cotangent. I always work with tangent. I'm going to do tangent of 225, and then I'm going to flip it over. So I come around 225. I'm in quadrant 2. What happens in quadrant 2? The tangent is negative. And then I think about a 45, 45, 90, and I have a 1, 1, square root 2. Oh my gosh, it's negative 1. What happens when you flip over negative 1? It's still negative 1. What a wonderful deal. All right. 315. We press on. 315. Quadrant 3. Bow tie. No, 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 no. No, 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 no. Remember, those are the angles we're talking about. So I'm talking about this guy right here. I'm 45 short. I need a 45, 45, 90 in quadrant 4. Tangent in quadrant 4 is negative. How do I know that? The cosine is positive. The other two are negative. That's what we use the STC for. So I know I'm going to get a negative, and I know tangent is, of a 45 is 1 over 1, so I get negative 1. Cosine is 60. Don't forget about quadrant 1. It's no big deal. The reference angle is exactly what it says it is. It's 60 degrees. And we know that cosine in quadrant 1 is positive because everything is positive. Look at your SOHCAHTOA. The cosine is equal to the adjacent over the hypotenuse. It's 1 over 2. Oh no, radians, not that, anything but that. So what you can do is you can transpose these suckers into degrees. That's 45 degrees, right? 180 divided by 4. So I get a 45. How many 45s we got here? That's 1 again. I'm in STC tells me everything is positive in quadrant 1. Negative pi over 3. Change that. Use your little conversion. I get negative 60. Ooh, I'm in quadrant 4. But quadrant 4 for cosine, STC. Cosine is positive in quadrant 4. How lucky are we? And then I'm going to get, I got a 60-degree reference angle. Don't forget your bow tie. 60-degree reference angle tells me that the adjacent over the hypotenuse is 1 over 2. Okay. Let's see. The ride here, what are we doing? The swing arms on the ride pictured below are 89 feet long. And the height of the axis is that. What is the total height of the ride at the peak of its arc? So what we're looking for here is if I'm, here's my angle. Here's my reference angle I'm looking for. Okay? I went 20 past the negative 180. So I'm really looking for the opposite over hypotenuse. So I'm going to do sine of 20 degrees equals y over 89. And I just using regular SOHCAHTOA here. I got a 20-degree angle, and I got that from the 200. So I set up a proportion and solve, It's too late to cross multiply. 89 sine 20. And that gives me 30.44 feet. 30.44 feet. So how high is the water, Mama? Add on the 99. I get 129.43 feet high. Don't let go. Don't drop your phone. Have a great day.